Hello and welcome to Slack Chat Podcast, episode 9, with your hosts, me, Stuart Winter, the architect and developer of the Slackware ARM port, and Phil, who's the maintainer of the SAPI project, which can help you get Slackware ARM onto the Raspberry Pi. Hi, Phil.
Hi, Stuart.
How are you doing? You all right?
I'm very well, thanks. How's yourself?
Yeah, I'm pretty good, thank you. Pretty good
Excellent.
this evening. It's a nice evening. Hey, Phil, we've been talking about getting some guests on the podcast for a little while, haven't we? And
We have.
today we have a guest. We have a guest indeed. We have Angel Montanez, who we've come into contact with through the Slackware ARM project, and he's come into contact with Slackware ARM through the Raspberry Pi. So he's been using Phil's work, and he's come on to talk to us today about how we got into the project and what he's been working on. So, hello, Angel. How are you doing?
Doing good. How about yourself?
Yeah, it's all good. It's a nice, peaceful evening here in the UK. And the weather's good. It's not raining anymore. Actually, it was raining a lot.
It's been raining a lot here too, and finally the sun's out, so that's good.
Where are you based then at the moment?
South Carolina, which is in the east portion of the United States.
Ah, okay. I've only been to North Carolina, where Red Hat was. That's where they is.
Yeah, that's right. Yeah,
headquarters was. Oh, right. Okay. And you're from Spain originally?
No, actually, I am from Puerto Rico. I am from it's an island, little tiny island in the Caribbean.
That sounds great right now. I'm picturing this sort of like tranquil, picture of the island.
Although my family from my dad's side came from Spain, so a couple generations removed.
Cool. How did you find yourself in the US then?
Well, I moved in 1996, back when I finished high school. I wanted to study meteorology. I liked the weather. We had a hurricane in 1989 called Hurricane Hugo, and that's what sparked my interest in weather. And at the time, Puerto Rico, we didn't have a meteorology school, so I had to find a university in the United States that had that major, and I ended up attending Florida State University in Tallahassee, Florida, and that's where I got my meteorology degree, and that's where I started working with computers and getting an interest with it. We used to have Unix boxes for the lab, so that's where I first started getting my taste of computers, and especially the command line, which was pretty cool. And that was I left my country in '96, and I just stayed in the United States after that.
Oh wow! So what were you using there? Was it Linux, or was it sort of Unix boxes?
So yeah, at the time I always wanted to work for the National Weather Service, and that is the agency that I've been working with for the last 20 years. And I started volunteering my time when I was still going to school at the university, and I started volunteering when the government had decided to migrate, or the Weather Service, they decided to migrate away from HPUX to, no, not yet. We had just gotten HPUX boxes, and we had those for a couple of years. Then about the 4-year mark, since we had gotten those, they started to migrate away from HPUX to Linux. And by the time I had graduated in 2002, I went to my first office in Alabama by the coast. And while I was working there, one of my coworkers, he was showing me around all the computers. I was like, "Oh, what is that?" And it was actually a Slackware box, and it had the desktop. It's in pasture. It's been in pasture for a long time. It was not FE. It looked like a Windows kind of GUI, but not quite. It was not FV.
I know which one
Windows
you mean.
95, and I cannot remember.
Was it XWFM or something like that?
Yes, something like that.
Right.
And it was actually one of those machines, and it was actually used in every office to generate a lot of precipitation data and and I thought it was cool, and I was like, oh, what is this? I was like, oh, this is Slackware. So he's like, yeah, can you put this on my computer? He's like, sure. So that was it. I was hooked. That was my first Linux distribution that I tried. I also tried because the government when they started transition into Linux, they needed a corporate, of course, backing. So we went with Red Hat. And I remember, I think it was Red Hat 6.2 was one of the first versions that we were starting to use, and then we eventually went into Red Hat, the old Red Hat 7, not the 7.
Oh yeah.
Yeah, the old stuff, and it just progressed from there. And the weather service actually is a big Red Hat shop. All of our critical systems run on Linux, on Red Hat. The radar, how we generate the forecast, all the servers. So it's you have to know Linux. We obviously do have Windows machines for our regular desktops for emails and things like that, but all the mission critical stuff, that's all Linux, which is is pretty cool. So that's what we use now. I think we're Red Hat 7. The Enterprise, not
the Rail 7.
Yeah, Rail 7, and we're about to switch to 8 here maybe next year. So yeah, that's how I got into Slackware, and then I moved to Birmingham, Alabama, which is not England, but Birmingham, Alabama, and that's how I met Robbie. Robbie lived not that far from where I lived, and I knew I saw him in on Linux questions. I'm like, oh hey, he's from Tuscaloosa. That's not that far. So we connected, and actually saw him not long ago. I had to go back to work for a work trip in Tuscaloosa, and we got to have dinner and talk for a little bit, and I learned a lot from him. So, and over time, I just kept growing in Linux. I mean, like the job that I have now, even it's I did meteorology and forecasting for about 14 years, but my love for computers and Linux and learning how things work just kept growing. So now what I do, I still work for the weather service, but I work as the IT. I do a lot of I maintain the software now. I maintain the hardware, not all the hardware, but a lot of doing the installation patches and things like that. And I can attribute Slackware in getting me to where I am because it's, I don't know how to explain it. It's just how it works. It just teaches you, it taught me how to properly troubleshoot a problem. Okay. Since you have to kind of do everything by hand, you have an idea of how things work. And if you're doing things with Red Hat and things break, yeah, you can eventually figure it out. But the way I've always, building stuff from source, having an understanding how kind of what the kernel does, modules, because you have built kernels many times. I just had that understanding, so it helped. I don't think if I hadn't used Slackware, I don't think I would have the job that I have now. So I'm very grateful for that. And I feel even now, I think almost 20 years using Slackware or Linux in general, I'm very grateful for the things that I've learned, but I feel like I have not. I still feel like I don't know everything. Like there's so much to learn. So I'm constantly trying to tinker around and now learning the ARM architecture and trying to build packages for that and learning the quirks, because there's some packages that won't build correctly. You have to add some things, and you have to get your hands dirty, so to speak, and really get in there. So yeah, I'm definitely enjoying it and feel like I'm at the how do you say at the peak of my career of Linux.
Yeah, you've been doing it for a long time then, haven't you? 20 years. Wow.
Yeah, and I looked back, I was like, yeah, it sure is, about 20 years. I think, of course, the last 5 years is where really my knowledge has, you
Oh
know,
yeah.
increased. And, I've been able to get a couple Red Hat certifications. I got the system administrator
Oh yeah. The
certification.
RHCE, is that what it's still called?
Yeah, still RCA.
Oh yeah.
They changed. I was gonna do the 8, and they kind of changed things around a little bit. I think the RHCE now is all Ansible. So it used to be, Ansible had its own certification, but now RHCE is strictly it's all Ansible. So it gets pretty elaborate. So I'm slowly going through the training right now.
What do you mean by? I know the name Ansible, but I'm not. It's not connecting for me what it is.
Ansible is like it's Python mixed with SSH, where rather than you going in and
Oh, okay.
typing each command and sending it out, you create this playbook and you type everything that you want to do to either one machine or a group of machines or 1,000 machines. You put the playbook in, you say, I want this done, execute the playbook, and boom, that's it. It goes out and it tells you, hey, I was successful on this machine. I was successful on this machine. Oh, nope, something failed here. And then you
Ah,
and
it's a
then check.
config. It's like an orchestration tool. It sounds like
Yeah, it's kind
CF
of
Engine or Puppet or something like
yeah,
that.
Puppet, but much better. Puppet
Terraform.
is I don't Puppet is a little bit more difficult, but uh, 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 it's they use it's not an XML type, but it's a type of YAML file.
Okay.
I think that's what it's called. So it's a
Oh,
little,
Puppet uses YAML. Yeah, Puppet
but
does.
even Ansible does too, and
Oh,
so it's
okay.
easy to kind of find what you're wanting to do. Like for example, if you want, let's say, you want Apache to you want to make sure that a group of computers that are supposed to be providing web services, you want to make sure that Apache is installed. You create a playbook, and rather than you going one by one and doing that, the playbook will do it for you. So it's really powerful, especially for corporations or if you have to maintain thousands of computers,
Yeah.
you can easily do it. And if you do run into problems, you get a report back whether whatever you ran, if it was successful or not. So you can then
Yeah.
go back and see, okay, I have a problem here. Why do I have a problem? These machines should be all the same. So
Oh yeah, I really like that. We used when I was at Red Hat. We used GNU CF Engine and with loads of hacks in it, and then eventually switched to Puppet. And I remember looking at the YAML stuff, thinking, "What is that?" Someone else had had taken a lot of examples and made something that worked, but it was I never really I never really got my head around exactly the format of it. I could change someone else's because it's pretty obvious, but writing it,
right from scratch is a
from
little
scratch, it's like not
tricky.
going to happen. No, I never got my head around that. But it was a
No,
really good tool though. So I really like the fact that you kickstart, you'd install the machine, and then you just tell it you're like you said, you're a web server role, you're an FTP server, and then you're part of the Office group in Milan. So it would go and find all the settings and make that server be what it's supposed to be per role. So it took a lot
right,
of work
right.
to set it up to get that system like that. But once you've got it, it's just, as the Americans would say, cookie cutter, isn't it?
Right. And in the corporate world or in the government or whichever, that you got to manage so many computers, and they're
Yeah.
all like you can set up playbooks to make sure that your machines are in compliance. That services that need to be turned, be running,
Turned off and
whether it's SE Linux needs to be enabled and make sure that it's enforcing. You can have a playbook. And the cool thing is, actually, if you go to the Ansible website, they've done a really good job of providing documentation how to do things. I actually have sample playbooks, so you don't even have to start from scratch. You can just
oh
take
yeah.
those playbooks and modify them, and then bam. And a lot of them, they're already built in. You can just call them on the command line and just call them in, and you don't even have to write them. They're already ready to go. Pretty good stuff.
It's funny actually because when I was at Cisco, Cisco bought this little company just right before I joined actually. And apparently one of the things Cisco said, they couldn't understand how a team of 5 Linux sysadmins was managing such a large server estate. Like, how are you doing that? Like, because we've got it all automated. You just, you just go and see what the reports are, and you deploy things. Occasionally, you need to go and log in and massage something. Some particular
Right.
server's gone wrong, but ordinarily it just deploys like clockwork.
It is.
But
It is. Yeah, it's
good.
pretty amazing. And then now we don't do that here because our systems just kind of never change hardly. But like, for example, in the cloud, you can build these machines, and automatically with the Kickstart, you can execute the playbook, and within minutes you can have everything configured the way they need to be. You build, you get the image, you say this is going to be a web server, or this is going to be a file server, and automatically set it in the Kickstart to go grab the Ansible playbook for configuring the machine to be whatever. Makes it so much easier compared to what we had to do like just a few years ago.
Were you still doing stuff by hand, were you, a few years ago?
A few years ago,
Were you using Red Hat Satellite?
We actually, no, the problem is a lot of the stuff that we had, it sits behind a bunch of firewalls. So it in satellite, it's not cheap. So we do have satellite now, but it's for the longest time we didn't have satellite. So that was a bit of a pain to configure things. But once they were done and configured, they just ran, and they ran for a long time without any problems.
Are the servers configured as clusters, or is it a collection of different types of things? So, for example, clusters to analyze or render data.
So we have in the weather service, in a typical office, you have your main servers, and then we have a satellite dish that we get our weather data. The data is distributed from satellite across all 255 roughly offices across the United States and Puerto Rico and Guam, Hawaii, Alaska, and they, every station gets the same data, and we have a machine there that grabs the data, and depending on the weather service sends everything out, all the data, and each office then has a list of what they want. So that way you don't process everything. That's a lot of data to process. So it goes. We have a machine that's constantly listening to the data that's coming in, and it goes into these processes that we say, okay, I have this data. It goes into another place, and then somebody else requests it. It's pretty involved. But we have about 4 to 5, depending on the office, 4 to 6 servers that handle the data coming in and processing it and distributing it to wherever it needs to go locally for processing. And that includes computer model data for the weather models, satellite radar data from other Doppler radars across the nation. So it's a lot of data that we have, and then it trickles down into the workstations, and where the forecasters sit. And we use GNOME desktop, since that's the
Red Hat standard, isn't it?
That's the Red Hat standard. I won't say anything else. It can be tricky sometimes.
I've got nightmares about that.
Yeah, it's
Bad memories, I should say, not nightmares.
Yeah, it's a little tricky, so we have the servers, and then we have the workstations. The workstations run the GUI, of course, and then all the servers are just running. They're just running, without running headless, so to speak.
Oh yeah, of course.
And so yeah, I mean, it's pretty cool. We have our programs that we generate aviation weather, aviation forecast. We do fire weather. We do the regular forecast. Each office has an area of responsibility. So we we put out severe weather warnings, severe thunderstorm warnings, tornado warnings. There was just one very large tornado a couple days ago that went through Nashville, Tennessee.
Oh, right.
Yeah, it was categorized as an EF4. And I got
That bad?
it was
I don't know
bad.
Oh, right. I don't know. We don't have. I don't think we have those in the UK.
Yeah, I
Well,
mean,
we might have some categorization. I don't know. I've not heard of one though.
EF4 is winds in excess. It's winds between 166 and 200 miles an hour.
Oh, wow. Okay.
So that will.
Yeah,
that the difference between an EF4 and an EF5 tornado is that the EF4 will leave some debris, will completely destroy your house, but leave some debris nearby. And an EF5, everything is just gone. I mean, you're talking 250 miles plus winds. So yeah, it's pretty serious stuff. I don't miss working severe weather. It's a lot of stress. It's a lot of long hours. The weather service never closes, so we're a 24/7 operation. So it's.
Well, do you work 24/7 yourself? Then you're on call, or how does that work?
Now I work. We call them normal human being hours because I work Monday through Friday now, and but before it was you work day shifts 1 week, and then the next week you work evening shifts, and then another week you work midnight shifts, and you're constantly rotating, and it's really hard on the body. But now I work mostly Monday through Friday, and I'm on call, even though we're not really supposed to be on call, but we are. If there's a problem, I can log in remotely or go to the office and try to fix whatever issues. We have a certain level of support. We have a contractor that we can call and open tickets or call if we have problems with the system, and they're also 24/7. So it's a pretty elaborate system that we use, and of course it has to work. That's one of the important things with Linux is the reliability, and being that it's such a mission critical thing that we do. It's important to not be in the middle of a warning and then get a notification saying, "Oh, time for a patch." Gotta reboot. We can't have that. So it's a pretty intricate system that we have, and not to say that because we do use Windows, and Windows works well for what we need it for. It runs our file systems and DNS and whatnot. You got to use a tool that's going to work best for what you're trying to do. So, but back in quite a while, we used to have some SUSE boxes, and I don't think we ever had Fedora. They were always very strict. Well, they weren't always very strict what we could run, but now it's like either Microsoft or Red Hat. We can't put anything else. Not even CentOS. We can't put CentOS in there. But the mission critical, you don't touch that stuff. That's all controlled. You can't, But on the desktop, like on my work station, my regular on the non-critical system, I have a Red Hat machine. I don't, it's all Linux. on my in my cubicle, all my computers are Linux. I can't use Red Hat. I mean, I can't use Slackware, unfortunately.
You can't sneak it in like a virtual machine.
I can sneak it up every now and then as a virtual machine.
I've got one. I've got a virtual machine with Slackware on it on my Mac.
There you go. Or I can SSH, which most of the time I'm in the command line anyway. So it's all good.
So I don't know if you're allowed to tell me or not, but when I was, I've been to quite a few places as a sysadmin and other things, and quite often the systems that are in production, they actually don't get patched, hardly ever. Particularly if they're behind firewalls, or even if they've got some service that's exposed to the internet on some port. the people who've designed it have decided that the service is abstracted enough of, for example, let's say it's running Java, the service is written in Java, and they've decided that it's well contained enough and abstracted enough from the operating system that it'll be fine. So, for example, they won't patch ImageMagick, they won't patch libpng, they won't patch anything, because they've had, and it's pretty much the same wherever I've been. Is that you go and find these. I remember I went to a job interview once, and and it was for an e-commerce company. And they want, it was to look after some Red Hat systems. And I asked them about patching. They said, "Oh, well, we don't patch it." And they're supposed to be PC, the payment card industry, PCI. If you're handling payment details online, you can get big fines if you don't match up to certain requirements and whatnot, if you get breached and stuff. So anyway, they were supposed to be PCI compliant. And I thought, so you don't patch anything? And they said, "No, we don't patch anything because we find it breaks things." So they don't patch. And I'm like, "But hang on a minute."
It's like
there were loads of places that don't patch their servers because they've had a bad time in the past. So they might change, they might upgrade one package, but they don't patch the whole operating system. But if most of the system is all using linked libraries, so if you've got a hole in
right. Now I can say it, of course, because we do patch it. But before it was such a critical system. We had to be careful in how we were doing things. But I say about 8 years ago, the Willis service went through a process of modernizing the program that we use called AWIPS, and they modernized the hardware. I mean, not the hardware, but the software. For better or worse, it's written in Java, and but it's self-contained. So now we can generally patch our system and not really break the program. And of course, that's one of the benefits of using Red Hat or an enterprise grade level operating system, is that your ABI, a lot of the libraries are not going to change. So you can, and they backport a lot of the fixes.
They do, yeah.
Yeah,
they have to.
Yeah, so it's now we patch everything, even everything that's not even facing the internet. Everything gets patched. So they're very, very serious about that. But I understand why. A lot of places, it's like, oh, we can't do that. But again, this is, I don't know how you guys feel about that, but this is, I think, something that Slackware has taught me. I have broken the system so many times. I have getting errors while building stuff that I feel very confident. Like, I think a lot of people, as long as the system is working, hey, it's all great. But the first time they get an error, or some cryptic message comes up, people just panic, and they're like, what's going on? And they just, they just don't know how to troubleshoot. And I think that is a skill that so we automate so much that I wonder if that's a skill that's just not,
No, I get what you're saying. Yeah.
Yeah, it's an art that's dying. I'm like, I find it challenging. I'm like, okay, what broke? Why did it break? I see the problem here. SC Linux is blocking your request, or you didn't have something labeled correctly, or Firewall D has this service turned off, or whatever, or you didn't upgrade, this package didn't get upgraded correctly, or whatever.
Yeah, I agree with that. When I was at Red Hat, they used to have this. When you boot Red Hat and Red Hat 6, the old proper Red Hats, not the RHEL one, just boot like Slackware does it, with all the kernel messages and everything else just covering the screen.
Uh-huh.
And then they made the Red Hat graphical boot. I don't know if it's called that anymore, but so it would boot up and it would have a frame buffer with a logo, and it would hide all of the kernel boot.
Messages.
Yeah, and apparently that was done. I don't know if this is really true, but it probably is. Apparently they built the graphical boot because customers didn't like looking at what was on the screen because they didn't understand it. And these are supposed to be the system administrators. I don't know what it scares me. I just want to see a nice picture when it boots so I can click next or log in. But, yeah.
It is funny because I love seeing the boot messages. You'd be surprised how many things you will catch
Oh yeah,
in
just by
there. Yeah, but just by looking at it, it's like, oh shoot, that's some piece of hardware. I have an outdated firmware, or whatnot. So yeah, I mean it's just funny. I think a lot of it has to do obviously for the people that are coming in from the Windows world. You don't ever see boot messages on Microsoft when you're booting.
not by
So
default. No, you have
not
to
by
get,
default, right?
yeah.
So I prefer the boot messages. I had one time we had to build something from source, and my coworker was just completely just like he didn't understand what was going on. Like how when you're building, you're building something and you see all this code flying by, like, what's going on? I mean, is this working? What is it doing? I'm like, it's just building a package. You never seen this being done? It's like, no. It's like, oh my gosh. They just install whatever and off they go.
Yeah, I was talking to a customer the other day in my line of work. He was saying that some of the engineers now who are web developers, they don't even know HTTP. It's like, how can they not know the web protocol? If they're a web developer, I mean, you need to know how it works underneath so you can go make some informed decisions, because everything's become abstracted from the original. Even now the hardware is abstracted, it's cloud.
Right.
So everything's virtual. Of course, it's not really. It's the real server's still in there, but they're just not yours. But the further you get away from, the further, if you just deal with abstractions and high level views of things, you never really know what happens underneath.
Right.
So yeah, I do think it's a dying thing because it's just too easy to go and click next. But when it breaks,
right.
That's just don't know what to do. There's never a good error message for what's really happening.
Right. Right. Yep. You have to understand what is supposed to be happening in order to troubleshoot it correctly, or where to look. Yeah. Right, where to look. That's one of my frustrations. Every now and then I'll play around with Fedora, and I have to say Fedora's a pretty neat. It's come a long way. It used to be where I would load it up and I would give it a week before some update broke, and I would like reboot and be like black screen. It's like, oh, come on.
I found that with Ubuntu as well, actually. I tried. One of my friends used to work for Canonical for a bit. Actually, had a few of them did, actually. Ex-Red Hatters went there. It was kind of like the leaving. It was kind of like you'd leave Red Hat and have leaving drinks at Canonical for a year, and then do something else. So I thought I'll give Ubuntu a go, and I'll put it on my laptop, and it did. I ran an upgrade on it, and it just broke it completely. So I just put Slackware back on it straight away.
Right. Yeah. And that's what I usually do. Is like, I will run something else just to kind of see what's out there, and eventually I'm like, I will get bored. It's like, well, I mean, it works, but I don't, I will feel like I'm missing out on building stuff from source, or building Slack builds, or what. I feel like I don't know if it would be correct to say that, but I feel like I'm getting dumber. Like my skills are not being sharpened, and I'm like, I think the longest I've gone without having Slackware on my laptop or my desktop is like a month, and I have to go back. It's just like, okay, that's it. I'll just go back. And I know that I can do virtual machines, but I'm like, no, let me install it on real hardware, just kind of get my bearings. Because every now and then, there's some frustration with Slackware. Sometimes you want something to work, and you don't want to spend like 3 hours why the wireless card is not working. I'm like, why is this not working? So it can be frustrating at times, but that's the rewarding part when you figure it out. Oh, this is why it's not working.
I think that's what it is, though, isn't it? You have to kind of. I remember when I started using Slackware I think it was 90. No, it wasn't 98. I think it was. Yeah, 98. I've been using Red Hat since 96, and it's back in the days when you had XF86 config, which is just a shell script, I think, wasn't it? It just made some files, if I remember rightly. Anyway, so I tried to set up with this horrible SIS video card, and it was just complete. I didn't realize how it was a piece of crap. I didn't know anything about x86. It was just rubbish. But then, it worked fine on Red Hat though. But I couldn't get it working in Slackware. So I'd put the Red Hat I'd boot Red Hat on the machine and get a working config, and then I put it on my Slackware box. But I have to change something because something was always the wrong path. The paths were different or something. But basically, I could get all of the screen modes and all this sort of stuff about monitors that I really didn't want to know about, like frequencies and all that sort of stuff.
Right. It's like I just want it to work.
I'm not interested in monitors. I just want to watch the screen.
That's a good example that it can be frustrated at times, but again, it pays off because you have to look at these things into these config files, and every now and then like at work, when we changed monitors, something wasn't working, and if you're not comfortable looking at that xorg.conf, you'd be like, I don't know what, a lot of people are like, I don't know what this means. I was like, oh yeah, I've dealt with this before. This is what you need to do. It's like, oh, okay, because you have to get your hands dirty and you have to modify this stuff manually.
As long as you're prepared to look into it, I mean, and actually know, okay, I'm going to spend some time looking at what this actually means, what this actually does, then you do come away with a lot more knowledge, and it's just an investment of time in the end.
Right.
So this concludes episode 9 of this 2-part podcast. So tune into episode 10 to hear the rest of it.